Hello, we'll discuss about quantum numbers now. To explain the electron in an atom, we need four quantum numbers. For the complete explanation, we need four quantum numbers. The first one is principal quantum number, second one is azimuthal quantum number, third one is magnetic quantum number, and the last one is spin quantum number. Principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. They are given by N, L, M, and S. In this class, we will discuss about the quantum numbers, their significance, and the questions related to them. Done. So first one is principal quantum number. This is not principal, this is principal quantum number. Okay. So this is, you can say, the most important quantum number as our college principal or our school principal. Important quantum number, you can say that. It is given by Mr. Niels Bohr, regular point. It is denoted by n. The values are 1 comma 2 comma, like this you can write up to infinity, or you can say k, l, m, n, so on. N can never be 0. Remember this point. These type of questions only will be asked in your exam. N can never be 0. N starts from 1. What it indicates? What it indicates? N explains many things like angular momentum of electron. Angular momentum of electron is given by mvr is equal to nh by 2 pi beta. So N is going to decide the angular momentum of the electron. So angular momentum of the electron is decided by the principal quantum number. Next, according to Mr. Bohr, radius of orbit is equal to 0.53 into n square by z angstrom. Again here n is there, so it is going to decide the radius. Radius of the orbit is also decided by the n. Similarly, energy of electron. Energy of electron formula is minus 13.6 into z square by n square. Electron volt per atom, again decided by n. You can see here n is deciding again. So all these are going to be decided by n. Energy of electron, angular momentum of electron, radius of orbit, even velocity of electron. What is the velocity of electron? Yes, 2.18 into 10 to the power of 6 z by n. Okay, so all these are decided by n. How you are going to explain, and what are other things that you can say according to principal quantum number? Number of subshells is equal to n. Means if n is equal to 1 beta, then there is one s orbital. If n is equals to 2, there are two types of orbitals, 2s and 2p. If n is equals to 3, there are three types of orbitals, 3s, 3p, 3d. So this kind of subshells are given by n. Number of subshells is equals to n. Number of orbitals is equals to number of orbitals is equal to n square. You can say orbital, you can say orbital, you wish, n square. If n is equals to 1, n square is again 1 beta. That means 1s orbital is having only one shell. If n is equals to 2, n square will be 4. That is 2s orbital and 2p orbital. No? 2s orbital will be having one subshell. 2p is having 3 subshells. So number of orbitals, okay, now that means subshells, you can say orbitals will be 4 beta. 2s and 2p. If n is equals to 3, n square is equal to 9. 3s orbital, 3p orbital, and 3d orbital will be there. Sorry. 3s, 3p, and 3d. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 will be there, 9 orbitals. In the same way, number of maximum electrons is given by 2n square. If n is equals to 1, 2n square will be 2. 1s orbital can accommodate a maximum of 2 electrons. But If n is equals to 2, 2n square will be 8. 2s orbital and 2p orbitals are there. 2s orbital and 2p orbital with possible electrons 8. 8 electrons are possible. So number of subshells n, number of orbitals n square, maximum number of electrons will be 2n square. Maximum number of electrons will be 2n square. This is the importance of principal quantum number. Second one is azimuthal quantum number. Azimuthal quantum number is given by small l, explained by Mr. Sommerfeld. It is also called subsidiary quantum number. Subsidiary quantum number. Okay. Or orbital angular momentum quantum number also. Orbital angular momentum quantum number also it is called. Subsidiary quantum number also it is called. These are other names of azimuthal quantum number. L value starts from 0. It will be up to n minus 1. So your condition, your exam question will be, remember L cannot be equal to n. L is always less than 1, less than n, at least minimum by one number. L is equals to from 0 to n minus 1, can never be equal to n. Very, very important point. What it explains? If L is equals to 0, the orbital is s orbital. If L is equals to 1, p, 2, d, 3, f. Okay, these are the orbital values. Here, shapes of orbitals. S orbital is spherical. We'll discuss about the shapes in another class. P is a dumbbell. D is double dumbbell. F is four-fold dumbbell. These are the shapes. Dumbbell, double dumbbell, four-fold dumbbell, and this is special spherical. L is equal to 0, 1, 2, 3. 4 value is not there, but a G orbital, that is, we don't have any electrons in G orbital, so don't worry. 0, 1, 2, 3 values are only there. Okay. The meaning of S is sharp, P is principal, D is diffuse, F is fundamental. Sharp, principal, diffuse, and fundamental are the meanings actually. Shapes are spherical, dumbbell, double dumbbell, and four-fold dumbbell. What it explains? Orbital angular momentum, as we were discussing just now, it explains about the orbital angular momentum. It is equals to under root of L into L plus 1 h by 2 pi. In place of h plus 2 pi, that is under root of L into L plus 1, you can write simply h bar beta. H bar is nothing but h by 2 pi. Shortcut type. Orbital angular momentum is equals to under root of L into L plus 1 h by 2 pi. So many questions are already asked in a different examinations beta. For s orbital electrons. For s orbital electrons, what is the orbital angular momentum? Orbital angular momentum is equals to formula under root of L into L plus 1 h by 2 pi beta. For s orbital, the L value is 0. When this L value is 0, the overall will become 0. So for s orbital electrons, orbital angular momentum is 0. Now you see, if it is p orbital electron, L value for p orbital will be 1. So 1 into 1 plus 1, that is nothing but root 2 h by 2 pi. Other mathematical conversions you can do it by multiplying with root 2 and root 2 up and down. Then h by root 2 pi also it will become h by root 2 pi. That all these kind of simplifications you can make for p orbital electrons. For d orbital electrons, how you are going to say? See here, if they are asking about the d orbital electron, for d orbital L value 2 beta, 2 into 2 plus 1, so root 6 h by 2 pi. F orbital also they can ask, but most of the time they will ask you either d orbital or s orbital. S orbital 0 and d orbital, that is root 6 h by 2 pi. This is orbital angular momentum. Shapes of the orbitals and orbital angular momentum is explained by Sommerfeld in terms of azimuthal quantum number. Okay. Next, if n is equals to 1, L can be 0 only up to n minus 1. That means only one s orbital is possible. If n is equals to 2, L can be 0 and 1, and this orbital is 2s and 2p. This is called orbital designation. Orbital designation. If n is equal to 3 beta, what L values can be? 0, 1, 2. If it is 0, you can say this orbital as 3s orbital, this is 3p orbital, this is 3d orbital. N is equal to 3 is this number. L is equal to 0 means s orbital, 1 means p orbital, 2 means d orbital. So orbital designation type. So this kind of idea you should have to answer some questions. We are going to discuss those questions now. Next is magnetic quantum number. Magnetic quantum number is explained by Mr. Lande. This is given by M or ML because it is going to depend on the L values. Its values depend on L values. Its value starts from minus L including 0 to plus L. So magnetic quantum number values are going to depend only on L. Okay. So total number of M values will be, total M values is equals to 2L plus 1. If you want to write separately the individual values, then you have to go like this. If you want to identify how many values are there, total number of M values will be 2L plus 1. We'll see a few examples, then it will be easy for you. See, if n is equals to 1, L is equals to 0, then M must be 0 bit. If n is equals to 2, L is equals to, it may be 0 or 1. When it is 0, this is 2s orbital, this is 2p orbital, 2s orbital only one box, 2p orbital I am writing 3 boxes, you consider 3 orbitals better. So here this is M value 0, no other question, but here M value minus 1, 0 and plus 1. Now the question comes, which orbital should be given minus 1, which orbital should be given plus 1? Actually there is no proper condition better. Most of the books they will give you like this. If it is px orbital, this is py orbital and this is pz orbital. Generally this is not a mandatory thing. Generally that is given. This is plus or minus 1 and for this it is given 0. M values I am saying. Px, py, pz. For pz generally M value is taken as 0. If d orbitals are there, there will be 5 d orbitals better. dxy, dyz, dxz, dx square minus y square and dz square. Generally for dz square orbital we take M value 0. For x square minus y square and xy we take minus plus or minus 2. For these we will take plus or minus 1. Sorry. This is about d orbitals. Okay, L values and d orbitals. Magnetic quantum number values based on L values for d orbitals. What it explains actually? What it is going to explain? Very simple. It explains about the space orientation of orbitals. Space orientation of orbitals means orbitals, how they are arranged in the space. Px, py, pz, if any orbital you are mentioning like this. For example, if it is px, it is py, it is pz, like this if you are showing better. X means it is oriented along x-axis. Such kind of space orientation is given by magnetic quantum number. Okay, now magnetic quantum number explains about space orientation. Second thing is, what it explains is Zeeman effect and Stark effect. When we were discussing about hydrogen spectrum, there we mentioned this. Zeeman is splitting of spectral lines in magnetic field, and this is in electric field. Splitting of spectral lines in magnetic field is Zeeman effect. Splitting of spectral lines in electric field is Stark effect. What is this? For example, beta, if electron is falling from second level to first level, if electron is falling, then according to Mr. Bohr, only one line is formed. But that may be from 2s orbital, that may be from 2px orbital, 2py orbital, 2pz orbital. So actually this is not one line, this is a union, or it is a combination, it is a mixture of 4 different lines beta. In simple ones we can say, that means more than one line is there. Okay, now in this one line actually more than one line is there, that is only called splitting of spectral lines. Okay, splitting of spectral lines. In magnetic field is Zeeman, in electric field is Stark, and that is explained by the magnetic quantum number. The last one is spin quantum number. It is given by S or ms. Spin quantum number, it has only two values, plus of and minus of, given by Uhlenbeck and Gauss-Schmidt method. These values are independent, they are not going to depend on any n or l or m. Okay, now independent values. Generally clockwise rotation of electron on its own axis is given by plus of, anti-clock is given by minus of. Plus of and minus of. And spin angular momentum of electron is given by under root of s into s plus 1 h by 2 pi, where s is spin multiplicity, which is equals to 2s plus 1, where s is total spin beta, total spin. Okay, if two unpaired electrons are there, plus of like that. If one pair of electrons are there, plus of and minus of. So s is total spin, and here what s you are using is spin multiplicity, and under root of s into s plus 1 h by 2 pi. This is about spin angular momentum. Orbital angular momentum is generally asked. Spin angular momentum is very rare, it can be asked in exam. So this is about different 4 quantum numbers. Spin quantum number explains about the spin of the electron. Magnetic quantum number explains about the space orientation, Zeeman and Stark. Azimuthal quantum number explains about the shapes of the orbitals, and orbital angular quantum number, orbital angular momentum. Principal quantum number explains many things like radius, energy, angular momentum, like that. What questions they can ask you? Okay, few questions we'll see. And general question is NLMS values. They will mention NLMS values are given, which set is not correct, or which set won't represent any electron. For example, you see 1 0 0 plus of, is this correct set? Like that they will ask. It is a correct set. N is equal to 1 possible, L is equal to 0 possible, M is equal to 0 possible, spin plus of possible beta. So this is a correct set. 2 1 0 minus of, is it possible or not? When it is 2 it can be 1, when it is 1 it can be 0, it can be minus of. So this is also a possible set beta. N L M S values I am writing 0 0 0 plus of, n value can never be 0, so it is not possible. 1 1 0 plus of, n and l values can never be same, so this is also not possible. N and l values can never be same. N L M S values I am writing 2 1 2 plus 2, you say minus of. This is not possible because m value can never be l. M values are from minus l to plus l, it can never be l value, so this is again not possible. 2 1 1, you say plus 1, and this is 0. S value can never be 0 beta, so this is not possible. These kind of questions they can ask you, and you need to answer. For example, 3d orbital, what are n comma l values? N value is this number, d orbital l value is 2. Otherwise they will ask you n is equal to 5, l is equal to 0, which orbital it is? 5s orbital. Okay, so we'll discuss few more lines about shapes of the orbitals in next class. Till that time, it's Lakshma. Good day.